Let us start module 3, binary relation. Let P and Q be non-empty set. A binary relation is defined to be subset of P cross Q from a set P to Q if A comma B belong to R and R subset of, R, you read it as subset, R is contained in R subset of P cross Q, then A is related to, we say this number A is related to B, then A is, this is then, then A is related to B. It is denoted by A capital R B. I'll read it again. P and Q be non-empty set. So you know what is non-empty set, right? So we have some elements. P and Q have some elements. P and Q be non-empty set. A binary relation. What is binary relation? A binary relation is defined to be subset of P cross Q. It's defined to be. So we have to find P cross Q. We have to find P cross Q, and here binary relation will be subset of this one, subset of P cross Q, that is from set P to Q. If A comma B element of R, so we define a relation R. We define a relation R and A comma B belong to R. A comma B belong to R and R is subset of P cross Q. R, element of R belong to P cross Q. R is subset of P cross Q. Then we say this A is related to B. So we have two non-empty, I'll repeat, P and Q are non-empty set. We have some elements. We have to find P cross Q and a relation R is defined and A comma B belong to R, A comma B belong to R and R belongs to, R is subset of P cross Q, R is subset of P cross Q. Then we say A is related to B, small a is related to B. It is denoted by A, R, B, A related to B. So we'll see an example question. Example 1, let P is equal to A, B, C. P is A, B, C. Q is R, S, T. R is equal to, so relation R is A, R, A comma R, B comma R. Then again B comma T, this is B comma R, then B comma T, C comma S. C comma S. So when you look into this, we know P cross Q. How to write P cross Q? P cross Q is A comma R, A comma S, A comma T. A comma R, A comma S, A comma T. Then we have to consider the second element. Second element B comma R, B comma S, B comma T. B R, B S, B T. Then you consider C. If you consider C, C R, C S, C T. C comma R, C comma S, C comma T. So this is P cross Q. Then R is subset of, you see R, A comma R, B comma R, then B comma T, then C comma S. All the elements are here. So R is subset of P cross Q. R relation, R is the relation and R is subset of P cross Q. So we say every element like this, A is related to R. So we can tell like this. If you take this relation, A is related to R. B is related to S. B is related to T. C is related to S. Like this. So this is example 1. So when you come to example number 2, you see A is 1, 2, B is 1, 2, 3. A cross B, first you have to write A cross B. that is 1 comma 1, then 1 comma 2, 1 comma 3. Then you can write 2 comma 1, 2 comma 2, 2 comma 3. So this is A cross B. Then how we define R? R is defined as set of all x comma y, set of all x comma y such that or x comma y belong to A cross B such that x is less than y. Such that x is less than y. So how to find this? How to find this? So now after writing A cross B, R is defined as set of all x comma y element of A cross B. X comma y belong to A cross B such that x is less than y. X is less than y. So what this is x and this is y, right? X comma y, x comma y. So x is less than y. 1 is less than 2. Here this is x comma y. 1 is less than 3. Now here x is not, 2 is greater than 1. Here 2 is equal to 2. Here x is x comma y. X is less than y. 2 is less than 3. So we have the possibilities. You see, 1 is less than 2, 1 is less than 3, then 2 is less than 3. So 1 comma 2, 1 comma 3, 2 comma 3 because x is less than y. 2 is less than 3, 1 is less than 3, 1 is less than 2. So this condition is satisfied for these three relations. So R consists of only 3 elements and also here 1 is related to 2, 1 is related to 3, 2 is related to 3. Okay. So now we will continue with the next definition. Okay, now equivalence relation. We are going to learn equivalence relation. Equivalence relation, the relation R. Okay, the relation R on a set A is called an equivalence relation if it satisfies the following properties. So a relation R, now we learned what is relation in the previous definition. Binary relation we learned. Here we are going to learn equivalence relation. A relation capital R on a set A is called an equivalence relation. A relation capital R on a set A is called an equivalence relation if it satisfies the following properties. So property 1 is reflexive. Relation R is reflexive. Okay, relation R is reflexive if A related to A. If A is related to A for every A in capital A, that is A comma A element of R. So if you take R, suppose A contain 1, 2, 3, then A should contain 1 comma 1, 2 comma 2, 3 comma 3. What do you mean by this? 1 is related to 1, 2 is related to 2, 3 is related to 3. So that means A should be related to A. So it is defined in general for every A in A should be related to A. Then we say R is reflexive. Then next thing is symmetric. Symmetric means we say the relation, okay, relation R is symmetric if A related to B implies B related to A. That is A comma B element of R belong to R. Okay, capital R element of R implies B comma A element of R. Suppose for example I am telling A contains 1 comma 2 means then 2 comma 1 also will be there in R. That's what. Then we say R is symmetric. What is symmetric? 1 related to 2 means 2 is also related to 1. That's what defined here. A related to, you see, A related to B implies B related to A. Okay, that is A comma B element of R implies B comma A element of R. Then we say R is symmetric. Then we say relation R is symmetric. Then transitive. Transitive. Okay. What is transitive? Transitive means TRAN. Okay. Transitive. Transitive means a relation R is transitive. Transitive if A related to B, B related to C implies A related to C. A, okay, that is A related to B and B related to C, then A related to C. A related to B and B related to C, then A is related to C. A comma B element of R, B comma C element of R, then A comma C implies A comma C element of R. Okay, that's the definition here. That means A related to B, B related to C, then A will be related to C. That is A comma C element of R. A related to B, B is related to C, then A is related to C. That implies A comma C belong to R. So this is transitive. Okay, this is transitive. If this condition exists, then we say R is transitive. That means R will be, for example, R will be like this: 1, 2, 2, 3. Okay, 1 is related to 2, 2 is related to 3. Then 1 should be related to 3, 1, 3. If these three combination, these three pair is in R, then we say R satisfy transitive. That means 1 related to 2, 2 related to 3. Then 1 should be related to 3. That is also here. This implies 1 is, so we have these three elements here. Okay, these three combination. Then we say that is transitive. So now we will continue with some problems.